On the Steiger Olson report, lens flares explained, a physicist's thoughts, January 22nd, 2017. It's fresh off the presses. Wayne, isn't this fun?
This is fun. I tell you, I look at it like this. I'm sitting in class, I'm taking my notes, and you know, that's how I approach every one of these.
It reminds me of afternoon, science class in high school where, where we had to sit down and listen to science. You know what I mean?
I kind of look at it almost like I almost look at it like I'm getting a private tutor session.
Right.
I'm getting an opportunity to hear the thoughts of a physicist.
Right. And what we're going to do is we're going to walk through this paper and, point out some highlights. It's going to take a few minutes, but I encourage you to take the link below where you can go straight to my Google Drive and download the paper and read it yourself. How's that, Wayne? Free from the Steiger Olson report.
Oh my God, free?
Yeah, well, freely given, freely gotten, freely given.
Let's work. Let's go. All right, so I'm going to take my seat in the first row here.
Okay, so in this article, we are trying to discuss lens flares in more detail than we've ever tried before, and that's why I think this is the authoritative paper on lens flares in the Nibiru Wormwood Planet X brown dwarf community. Okay, a lot of diagrams are going to be used in here. So basically, lens flares are, depends on, of course, on the object. Let's start with a simple situation of bright orange light. And then basically, as you look through a lens, we go through and explain how lens flares are created in lenses. So don't ever, ever, ever try to preach to me on this again. I have, somebody who's pulling, their own thoughts and theories on this that has been trained in all of these scientific principles, a theoretical physicist. And so I'm being educated by the best right now. And I encourage you to read the paper yourself and critique it. But some of the things that I want to go right away to is basically the debunking of what some people call lens flares, and then what we know to be our actual objects that are being obfuscated in space. Okay? So far, so good?
I'm following.
All right, so basically, you jump ahead, and I'm already on figure 8, and this is where it gets interesting for me, is basically the white and magenta symmetric light source, which you explained earlier in this article, which is, she proves is artificial and therefore a sun simulator. Okay? So if that doesn't what make you want to read everything up to this point, then you're not really interested in this subject. You know what I mean? So I'm going to give it to you this way. I go right to the conclusion of these papers, okay? And I'm going to run right down here. Figure 10, we're actually looking at artificial objects in space as proven and as explained by our physicists. And then furthermore, the conclusion at the end of this whole article, which is right here. Light going through a lens creates a lens flare of objects in the sky, but a bit of understanding of how they're created and work can help us analyze photographs and video footage, and also help us better understand the systems that have been placed around our planet designed to hide the truth from us. So lens flares can actually be very helpful in our search for the truth. And here, just kind of in the last figure she has in this paper, the lens flare created by the lens system between the sun simulator and real objects in outer space and the camera on the Earth's surface. And it is an amazing paper, Wayne. And again, I'm not trying to bore everybody with the academics of it, because there's plenty of them in here. I just want people to go download this white paper themselves.
Yeah, and I've been thinking as you were scrolling through there, and I've read this, that when I think about the projects that are unfolding in space right now through privateers, through other governments, and you begin to think about people, the idea that there is a shield even anywhere on our planet is absolutely, to most people, the most far-fetched, most ridiculous thing to think about, until I showed them the pictures that we get off from the ISS. And then they ask everyone, what is that? What our physicists showed here, okay, I happen to know that it is up there. I've seen enough of the footage off of the ISS to know that there's something up there. Now, Is this a planetary-wide shield? I don't think so. I think that the cost for something like that would be too prohibitive. But do I think that there are, in fact, either prototypes or production models out there? Yeah, I do. The Russians have already shown us, Steve, that they have not only shown the concept, but I think that they're in full deployment. We never hear what the Chinese are doing. And that's the other disconcerting thing to this. The Chinese...
The other disconcerting thing is the saber rattling they do on planet Earth while they cooperate, it seems like almost to precision in space.
Yeah, but my concern is that I don't see any press information being released from China. They are actively involved in space. They're actively involved on the moon. They have, I think, their third rover up there now. They have said indications that they're going to possibly go to Venus. So what my whole point to this is, we're taking the basis that NASA is our filter. Our physicist shows us, well, okay, but here is the science. Let's look at this and let's see what the science is showing us.
Right.
Yeah.
And by the way, the good news is that as we've been on our journey here over the last year, we're looking at this and going, okay, so we're trying to look at this with true trained physicists and scientific approach the best we can. And we've been looking at it for so long, and all you have to do is go back and look at the history of WSO and Wayne Steiger videos, and you'll get a plenty dose of how we came to these conclusions. But it's really cool when a physicist comes and says, okay, you know, what you've kind of trained yourself to see as being real and not real is pretty dang close. And I'm pretty happy about that.
Well, it is so true, and I like how you brought this up. So if I've been trained in a particular discipline, right?
Right.
And let's say I use the standard model.
Mm-hmm.
And that's how I was trained. That's how I went through, let's say, the apprenticeship, and then became a journeyman, and then became a master, right? And then you come along and you inject another theory, right? And I'm saying to you, that's impossible. You don't understand. We have full science about this. But you come back and you say, well, but I do as well. That's what I see science ever unfolding. And this is a great paper. I've actually did a video that I'll be posting on this one on my channel, because this is a phenomenal, in fact, it's already posted. It's a phenomenal paper. I actually go through it word for word.
Well, and I refer everybody to, you know, our Wayne Steiger channel and WSO main channel. And this is the new Steiger Olson report channel, which is going to be branded here on the 23rd of January. And I'm glad to be in partnership with you, Wayne, as we try to take this thing forward together. But this gravitational engine, why don't you walk us through just the highlights of this paper for the Steiger Olson audience? And then if you guys want to go and check out Wayne's video on the R Steiger channel, go ahead.
Yeah, so this actually came from a subscriber who sent this question in. And it's a great paper, because when we talk about what Einstein theorized about a black hole, that in a distant galaxy, right, if that light was coming and there was an object in front of that light, well, that light would be concaved around that object and would come out on the around the object. And we see this again in the Einstein cross. And
a dramatic story behind the guy that helped Einstein prove that during a very turbulent time in Russia, when they actually got a measurement that actually measured gravitational lensing around the sun.
Precisely, and she gets into that because with the sun, it's like you're dealing in milliseconds. I mean, it's very quick. The normal telescope here on Earth would never catch it, but an instrument would. But this is what I find so fascinating about light and what we see here on planet Earth. And our physicists get so well into the complete theory behind this of how the lensing effect happens. And the question I always think about, well, when we're in close proximity to our sun, could there be like Mike Brown over at Caltech had said that they had seen planets that were basically invisible. Well, it would be invisible, I guess, if there was no right light, that were immensely huge. And I often sometimes wonder is that if we could have objects that were not, I guess I know this sounds far-fetched, not in complete phase, right? Could that have an impact of what we see a lot of times here on Earth? I don't know. It's a good paper, Steve, as you'll see, as you read the conclusion. See, that's what she was pointing. It happens with our sun. We just don't see it.
Right, and the thing of it is that we're trying to get a better grasp on what we're looking at when we look up in the sky, and we hope that this helps everybody. These papers are going to be made available in the links below, and again, you can just download the paper from our Google Drive and have at it. And if you have any other questions, please send them in for now to olson.steven.d@gmail.com. And I'll pass those questions on to Wayne and the physicists and other people that we have in our network for the best possible answer we can come up with. So hope you enjoy the papers. And Wayne, thanks again for your time and your efforts in this new endeavor.
Hey, it's going to be fun, Steve. I think everyone, listen, again, we really appreciate you. We always say be kind to one another. And listen, we're probably going to stumble along the way, but that's the whole process of learning, Steve, is that we learn from our mistakes, we grow, and we continue on. And the quest for knowledge is one that I don't think ever stops. And I hope that we can bring a perspective of awe back into what we all see. That's what I hope, Steve.
Yeah, me too. I just want to dive off the diving board. I feel a lot like that little nervous 7-year-old on the big high dive. And I just want to jump off the board for the first time because I have a feeling that we're going to be able to, have a controlled fall at least.